Oh look, it's flexible. But is it tough too? Hello, welcome back. I have a new filament type again on this channel. This is PBT Pro by CC3D. And the reason why it is here, because MakerMuse created a video about it, and since that I was bombed by requests to test this filament too. And this reminds me to the Tulomer when the 3D Printing Nerd created a video about it, and also I was bombed with the requests. And I have a message to these popular YouTubers, so before you create a video about a new filament type, please inform me so I can buy it before it is out of the stock. PBT I tested so far as a mix with polycarbonate, for example by 3DO. I have there the carbon fiber and the regular version, and soon I will test one by Polymaker 2. Now this video is not sponsored by the CC3D, I'm not paid by them to create this video, but this video is sponsored actually by the Polymaker, who became a channel sponsor too. And also from them I have the budget to buy any filament I want to test. Now back to this filament, and let's see a few specifications from the website. Dimensional stability and low moisture absorption. Ultra high toughness, this means it resists good to the impacts, and I believe that this will be the most important property of this material. Low printing temperatures, heat resistant between 100 and 130 degrees Celsius, different informations we have on AliExpress where I bought this filament and different on Amazon, and chemical resistant material. About the print settings, they are very similar to the PETG. Printing temperature, again I can see some different numbers here. Between 230 and 250 degrees Celsius on one source, on different source between 210 and 240 degrees Celsius. Now the printing speed is quite low, between 30 and 60 millimeters per second. I'm not sure is this some kind of older information, but bed temperature between 60 and 70 degrees Celsius, and the cooling fan turned off, which is again suspicious because even with the PETG I turn on the fan. Yes, I reduce it to let's say 50%, but never turn off completely. And maybe I will do some layer adhesion tests on different temperatures, and according to this I will decide on which temperature I want to print my test objects. Let's see what's in the box, made in China. It's in a black color plastic spool, vacuum packaging desiccant inside, and here we have some print informations. Print temperature 235 plus minus 15 degrees Celsius. The bag is not resealable. Interesting, I thought the surface will be smooth, but it is rough a little bit, almost like carbon fiber filaments. Yes, I forgot to mention it contains 5% glass fibers in it. Oh, it's not glitter at all. The filament is loaded into Bambu Lab X1 carbon. I will print on this printer with open doors because on P1P I don't have the hardened steel nozzle, and this material still has some glass fibers in it. And I will use the texture PI sheet without any glue on it. The temperature tower will be from 250 down to 220 degrees Celsius. The start is very good and clean. This is the third element on 230 degrees Celsius, and it looks okay so far. The printing is finished by adhesion check. Looks like it is good. The bed cooled down and it still sticks good, and the flexing is not helping much because this is quite flexible material. I'm trying to use that flexibility to remove the object, and it's still quite hard. Maybe I should use the glue. Okay. The quality of this temperature tower is good on any element. This is the overhang, except for the bridging. It's a little bit too big, but for my test objects I don't have big bridging, so I will try to print on 250 degrees Celsius. Since this is new filament type for me, I want to be sure about my choice for the print temperature, so I'm printing these layer adhesion test objects. They are printed with 2 volts and 0% infill, and they are printed by object on different temperatures. They are marked, and now let's try to remove them. Small surface easier to remove. Layer adhesion in function of temperature. A reminder, these are printed with 2 volts and 0% infill. Improvement is minimal, but it's there. Settings in the slicer: 250 will be on the nozzle, 8 the maximal flow, And this is the default part calling for generic PETG, which is my start profile for this material. And these are my regular test objects, but I will have two for the impact test, just in case. Printing is at 40%, and I'm quite sure that it will be okay until the end. And it's almost finished. Completely cooled down, and removing should be easier because of smaller contact area. Yes. And they're ready for mechanical testing. Actually, I need one more test object. This one is for the wearing test, because I don't have experience with this material, and it has a lot of similarity with the TPU, which is very resistant, so I want to check that. And also I want to check this printing where the bed temperature is only 60 degrees Celsius. Let's see if removing will be easier now. Ah yes, definitely. I noticed this is quite flexible material, but question is how much flexible. So I decided to print this GT2 timing belt. I already tested this in earlier videos. This is 95A TPU. And this is PBT Pro. Well, definitely more rigid, but maybe with a little bit bigger diameter it can be useful. This will be also a real functional part. Should be very impact resistant. A replacement for this pipe connector, which is broken now. And I'm quite sure that this will be much stronger. Of course I use more material, but this is the beauty of printing. I'm not limited to original design. Well, actually after the testing now I know that it is not so tough material, but even then it is better than original. Wearing test with this 3mm shaft, and the load will be 2.5 kilograms. Test the counter. Even now I can see that it is not so very resistant like TPU, but it will have 200 repeats. I cleaned the edges. Let's measure the depth of the groove. Has 0.2 millimeters. Definitely less than average PETG, but more than TPU. It's time to start the mechanical testing. And on screen you can see the average from 2. Layer adhesion. These are solid inside. Since print settings are very similar to PETG, I decided to compare to this material, and I have here 20 pieces in that summary table from my Patreon supporters. And on a tensile test we can see that PBT is noticeably weaker. Layer adhesion is weaker too, but it is somewhere between acceptable and good layer adhesion. Shear test, side by side horizontally and vertically printed. Weaker in both cases, but printed vertically the difference is smaller because of the decent layer adhesion. Twist test with horizontally and vertically printed test object. This one is printed in horizontal position. 0.6. 1.2. And printed vertically with the same dimensions. 0.6. 0.8. It's really rare that I can twist so much this vertically printed test object, but also this one was interesting too. And again PBT was weaker in both cases, but look at this number of the turns. This is very ductile material. This may be one of the advantages compared to the PETG, for example. Impact test, and I have that feeling that it will not break, but let's try. Oh, 0 position. Well, actually this is normal because I forgot that it has some glass fibers in it, and these fibers always makes the material more brittle. These are two edge positions of the hammer, and from difference in height I can calculate the breaking energy. And here I can see the first advantage of the PBT Pro compared to the average PETG. It is slightly tougher even if it is reinforced with glass fibers. And now 3-point bending test. With these loads, which will be placed one by one, and I will measure the deformation after 1, 30 and 60 seconds. Currently under 2.5 kilograms, I pay attention even now during this 1 minute it constantly deforms. This is now under 5 kilograms, and under 10 kilograms it couldn't even survive this 1 minute. Wow, look at this permanent deformation. It had very similar stud deformation like PETG, but after this it constantly deforms under any tested load. Definitely you don't want to use this PBT Pro under parts which will be under constant bending stress. I became curious about the hardness. This is Shear 8 durometer and I will measure on the top covering layer. 99 on Shear 8 scale. And what about Shear D hardness? This is sharper and the penetration will be bigger. 68.5 on Shear D scale. The creep tests deformation under the constant load, but I'm not sure how it performs here. It's quite flexible. Oh. 20.24 the start deformation. And I always measure them every day, but in a video I usually jump 5 days, but this is only after 1 day. I already measured it, but I'm showing this because I'm not even sure that it will survive 5 days. This is the last day. It slowed down with the creeping, but the deformation is huge. Let's measure it. 50.98. And let's remove the load. This is the distance between two reference surfaces, and this is the creeping, the difference between 2 days. And we can see that it reduced with the creeping after day 1, but it was constantly there even on the 5th day. And it was huge compared to any material, not only PETG. Temperature test in the oven, and this one is from the PBT material. M10 nut as a small load. And I want to record the temperature of the first deformation. The other two are graphene filaments, PLA and PETG, and on this PBT I noticed the first deformation only at 156 degrees Celsius. I stopped the experiment on 178 and until that it completely deformed. And our results one more time without any additional comments. And as always, this one line will be added to the summary table from our Patreon supporters, so they can very easily compare this data to any of those which I did in earlier videos. Huge thanks to them, because their donations, but together with the sponsoring by the polymaker, makes this kind of videos possible. And for the end, quite interesting material, flexible, but I couldn't find any big advantage of this material compared to some hard TPU. Maybe this one is more temperature resistant, but for example TPU is more wear resistant. So I don't know what's your experience about this filament. And if you like this kind of videos, just small reminder, but most of you who is watching this video already did this, subscribe and enable that notification bell button too, because in most cases my videos are not recommended to regular subscribers, especially not to those who are not subscribed. Thank you for watching this video and happy printing!